In today's lesson, we are going to look at how to graph a line. So we've done this type of question, or we've looked at how to graph an equation before, but now we're going to look at a different way because we're going to be looking at dealing with equations where our multiplier or our slope is a fraction. So the key thing we want to remember here when we're trying to graph a line or we're trying to graph the multiplier is we want to remember this new concept called rise over run. And this is just another way to say what my multiplier is. So my multiplier, I can say in the past, multiplier again, m, or slope, multiplier, rate of change. Again, all those terms mean the same thing. We've learned some new formulas. We know change in y divided by change in x. We've talked about it being represented a different way, delta y over delta x. We're now learning a new way, and this will help us focus specifically on graphing, called rise over run. Now it's still in the same formula, still meaning the same thing. It's just a different way to represent it, more of a visual way, you could say. Essentially what rise and run represent, rise refers to basically how far up or down, and run refers to how far left or right. So basically it's giving us directions on where to go to get to a point. So if I'm graphing this equation, y equals negative 4 over 3x minus 1. Again, the key things we should recognize, this negative 1 is our b value, which is the y-intercept. So right off the bat, when I look at an equation, I should be able to figure out where I'm starting. So if I look at my graph here, or my grid, I'm starting at negative 1. So again, we should recognize that where the axes cross is 0. So negative 1 on the y-axis, so the vertical axis, will be right here. So I'm going to have a point there at negative 1. Now, to figure out where my next point needs to go, I'm going to use my multiplier. So again, our multiplier, or this m value, is negative 4 over 3. Now because it's a negative fraction and our negative is in front, it could be negative 4 over 3 or 4 over negative 3. So when you have a negative out front, it can apply to either the top or the bottom. And we'll look at how that really affects how we're graphing it in a little bit. So that's my multiplier, 4 over 3, or negative 4 over 3, or 4 over negative 3. I want to look at the rise and run. So rise is the top number, negative 4, we could say if we're looking at the first one. So what that means from this point, I'm going down 4 spots. So I'm going down 4. The run tells me how far to the right, because it's a positive 3, so I'm going 1, 2, 3 spots to the right. And that is where I end up, is my new location for my next point. I'm going to do the same thing to go from this point to another one. I'm going to repeat that. I'm going to go down 4, 1, 2, 3, 4. So I'm going down 4. Just switch these around a bit. I'm going down 4. 1, 2, 3, 4. And then I'm going to the right, or in the positive direction, 1, 2, 3. And that's where my next point's going to be. So that was using the one way with the negative on top and a positive on the bottom. If it was switched the other way, all that would mean is that I'm going up 4 now. So 1, 2, 3, 4. 1, 2, 3, 4. So I'm going up 4 and to the left 3. So 1, 2, 3, which gives me a point in the other direction. So basically we're just reversing our pattern or heading in the opposite direction. Either way you look at it, you're still going to be able to get these points. So 1, 2, 3, 4. So positive 4 to the left or negative 3. And there's a new point. Now with all those points, I can connect them or basically draw a line through them. And there I've graphed my equation. So we've done this before when the multiplier was a whole number or over 1 because we knew for every one position what it changed by. We were basically doing rise over run. Now we're just kind of putting it more into practice when we have actual fractions and not whole numbers. So the steps are still the same, but now we actually have terms to refer to the top and the bottom number of our fraction in terms of our slope and where our points are going to be. We can use that same idea to come up with an equation of a line from a graph. So if I look at my graph here, I'm just going to redraw over these lines just to make it a little bit nicer or easier to see. So there's my axes. Again, if I'm trying to come up with the equation, I'm looking for y equals mx plus b. Anytime I'm trying to find the equation of a line or a rule, this is generally the format it should take. When I look at my graph, the first thing that I should be able to find is my b value. Again, we go down our axis, our y-axis, and where our line crosses is our b value. So if I look at my scale, 1, 2, 3, 4, 5, that means my b value is 5, or positive 5. So I know so far it'll be y equals something x plus 5. Now in order to figure out the multiplier, we've dealt with this type of situation before. We could find some nice points. So we have our b value already. If I follow the line and see where's a nice point, I find one right there. Basically what it means by that is that it crosses the grid lines nicely so I can easily get the coordinates or see where it ends up. So 1 on the y-axis and 1, 2, 3, 4, 5 on the x. And that will be helpful. Now we could go through, create a table similar to what we did in the previous lesson. X, y, we know 0 and 5, and now we know 5 and 1. And we could find the change in y, the change in y, the change in x, minus 4 plus 5, go through negative 4 over 5. So we could go through and do that step if we really wanted to, if we were unsure of how to do rise over run or the backup. But we want to keep in mind an easier way without having to go through and do the table. I have 2 points. I want to see how far do I have to run. 1, 2, 3, 4, 5. So I have to run 5 to the right or 5 in the positive direction. And then I have to go down 1, 2, 3, 4. So minus 4. So based off of my rise over run, my rise or the vertical was negative 4, the run was positive 5, so my slope is negative 4 over 5, which was the same thing I got from using the table. So regardless of which way you want to think about it, whether you plug 2 points into a table and calculate the m value by change in y over change in x, or by looking at the graph, you use rise over run. Either way you choose to do that, you should still end up with the same answer for the multiplier, which will then give you or help you fill out your equation. If we look at example 2, again, when we're given a graph and we're trying to come up with the equation y equals mx plus b, The first thing that we should be able to find is the b value, because we go all the way down our y or vertical axis and see where does our line cross. In this case, it crosses right at the origin or at 0. So we know right now that our constant or our b value is 0. We don't really have to even show that, because if I'm adding 0, I'm not really changing my equation. Now we need to figure out our m value. Right? So again, the main thing we want to do is find a nice point. So we see a nice point here, 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 here. It's all where it crosses the grid line nicely. So in this case, right, again, if we really wanted to, we could create a table, plug in our points 0, 0, 1, and 20, and figure out what our slope is by doing change in y over change in x. But again, use that as a backup when you have a graph, because it's easier possibly just to look at it and find the rise and run. So to figure out my run, I have to look, I can see, okay, I'm going from 0 over to 1. Now you could count squares, say 1, 2, but you have to keep in mind what each square represents. In the previous example, the square would count as 1, but here, based on the scale, each square represents a half. So this isn't 1, 2, it's actually a half and then 1. So my run is 1. And then vertically, we wouldn't say 1, 2, 3, 4. Based on the scale, we can see that each square actually represents 5. So we would actually say vertically it's 5, 10, 15, 20. So that means our rise over run equals our rise was 20 over our run, which was 1. We could simplify this to just 20. And this is our m value. So our equation then will be y equals 20x plus 0, or again, you could just take out that plus 0 if you really needed to. Again, if you're not too sure about rise over run, or you're not too confident with it, hopefully then you're confident using the change in y over the change in x, using the 2 points on a table, because in the end you'll still get the same answer. It's just a little bit easier to see from the graph. It's just visually seeing how we get it. As well, it's a lot easier to graph an equation knowing about rise over run. So just keep that in mind when you're going to graph an equation, that you want to be using rise over run to figure out where your next points will be. Again, if you're trying to determine the equation from a graph, rise over run is helpful because it saves having to do some calculations. You're basically just kind of counting jumps, but you always have the backup of using the table and then using the change in y over the change in x to determine that. So again, it's just another tool to help you determine the equation based on what information you're given.